Okay, so hello. Today we're going to talk about Mars, general information about Mars, and things for you to take under consideration. So when you're planning a human mission to Mars, you have to have certain things. And some of those things you're going to learn about today. Now, I'm not going to give you the answer to everything you're going to need. Part of this activity, this contest is figuring out what you need based on the information I'm going to share with you today. Now, there's much, much, much more to Mars than what I'm sharing with you today. So you have to think about all of that. And by the way, did any of you watch the SpaceX launch of the big rocket this morning? It was quite wonderful. Anybody watch it? Watch the replay on YouTube. It is the rocket that will be taking humans to Mars, to the moon, and then to Mars. And it was quite a success. It was a test launch. There were no people on board, but it was incredible and beautiful. So please go to watch the replay. It was amazing. So all about Mars. Here we go. If you have questions while I'm talking, you can put them in the chat or raise your Zoom hand. So a little bit about me. I've taught about Mars for about 20 years or so. And it's important that Mars is a complex and dynamic planet. This is what Mars looks like. So if you were in space and you were in a rocket and you were heading to Mars, you would see this view. This is one side of Mars. Does anybody know what that big feature in the middle of the planet is? You can unmute yourself and say it if you know. Okay, well, we have a lot to learn. Great. That is Valles Marineris. That is a very large canyon like the Grand Canyon, except it stretches from one end of the United States to the other end. So it's about 3,000 miles across. So it is a huge canyon. And then on the upper left, you'll see these little circles. There are three major volcanoes here and then another volcano over here that you can't see called Olympus Mons. Mars used to be a very volcanically active planet. Mars has no large sitting bodies of water, as you can see. It's all dirt, rocks, and dust. So think about if you were going to live on Mars for up to 18 months, what would you need? So today we're going to think about all the things we would need. So quickly, just a little history about Mars. It is regarded as the second most hospitable planet for the appearance of life. NASA has not, or any other space organization has not confirmed that there is any kind of bacterial life there or any other kind of life, but it does have everything you need to live there for a bacteria. Humans, we need to bring some stuff with us, which is the job you're going to have to figure out. It is the fourth planet from the sun. So we go Sun, Mercury, Venus, Earth, and then Mars. So do you guys think it's colder or warmer on Mars than it is on Earth? Anybody know?
Colder.
Colder, yes. It's colder because it's further from the sun and it has a very, very, very thin atmosphere. The atmosphere of Mars is only about 1% of Earth's atmosphere. So that's another thing you have to take into consideration. And it is not, there's no oxygen. It's just a tiny little speck of oxygen in the atmosphere. And we have about 20% oxygen in our atmosphere. So we have a lot of good oxygen to breathe. So you're going to have to think about how are your Marsonauts going to get oxygen when they get to the planet. Planetary data, these are, orbital data, how far away from the sun. You see this AU, that means astronomical units. An astronomical unit is the distance from the Earth to the sun. So it's about 1.5 times further from the sun than Earth is. These are distances when it's closest. Perihelion is when it's closest to the sun. Aphelion is when it's furthest. Here are the orbital periods. So this is the Earth days in a year on Mars, 687. So Mars's year is about twice of what Earth's year is. And it's inclined to the ecliptic. That's this. So inclination to the ecliptic. The ecliptic is the equator of the solar system, and it has a very small angle of an inclination to the ecliptic. The radius at the equator is 3,394 kilometers. The gravity is a third of Earth's. So you have to also think about that. What will happen to human bodies in low gravity? The axial tilt is about 24 degrees, so it's almost the same as Earth. So what do we know about Earth that is caused by the axial tilt? Does anybody know what the tilt of our axis causes on our planet? Hopefully you've learned this in science class.
Seasons.
Seasons, very good. The seasons on Earth are caused by our 23.5 degree axial tilt. Mars has a 24 degree axial tilt. So does Mars have seasons? Somebody? Anybody? Mars has seasons because it does have an axial tilt. It has summer, winter, spring, and fall. They just look a little different from our seasons on Earth. It has a rotation period. The day on Mars is 24 hours and 37 minutes. What's Earth's day? How long is an Earth day? Please tell me you know that. Somebody?
24 hours.
24 hours. So these are things that Earth and Mars have in common. They have a very similar axial tilt that gives Mars seasons, the same as Earth, and it has a 24-hour orbital period, rotation period a day. So Earth's day is 24 hours, Mars's day is 24 hours and 37 minutes, give or take. So very similar. So that would be good for our human biorhythms to live in a very similar day-night period. It does change over, if it's been a long time and you've been there a while, it might have some effects on you, but it is closer than most of the other planets and moons in our solar system. So that's good. The temperatures are, these are approximate and they may have been updated since I made this slideshow. Negative 87 Celsius and max 20 Celsius. It may be a little warmer than that, just with new data coming in. That means on the equator on Mars, on the warmest day in the summer, if you are in the United States and you don't know Celsius, it's about 70 degrees or so, which is reasonable. But at night, the temperature plummets very, very fast. Can anybody think of a reason why that I've given about Mars already, why it would get so cold so fast? Anybody have any ideas?
Lack of atmosphere.
The lack of atmosphere. So the thinner the atmosphere, the faster the heat goes away. So very good answer. When the atmosphere is thin, the heat just dissipates. It's like being in the desert. There's no humidity in the desert, so there's no water to hold the heat in the atmosphere. So if you've been in the desert and it's been hot, and 3 o'clock in the morning, it's going to be cold. Similar type of thing. So this is the size difference between Earth and Mars. So you see, Earth is about twice the size as Mars. But as Dr. Zubrin stated on Monday, this week, the land mass on the Earth and Mars is almost the same. So there's plenty of room for humans to go live there. There is a rocky surface, so you can land on Mars. You can't land on Jupiter, Saturn, Uranus, or Neptune. They have gassy surfaces. But Mars has a rocky surface. It has two moons, which if you have a good telescope on Earth, you can see them when the conditions are right, and bright polar ice caps. The polar caps of Mars are made of carbon dioxide ice and H2O water ice. So think about that. Maybe humans may make some use of that when you get there in your plan. So this is what the North Pole looks like on Mars when there's this big ice cap. And this ice cap grows and recedes on the North and South Pole of Mars. Again, here with the H2O and CO2, there are clouds, snow, and dust storms on Mars. We have video from the Phoenix lander that landed in 2008 of it snowing on Mars. We have tons and tons of video of dust storms, and there are many photos of clouds on Mars. They're not as thick as the clouds on Earth because there's not as much water vapor and not a thick atmosphere, but those things do all exist. So think about dust storms. Sometimes the dust storms will cover the planet for months at a time, and the dust is very fine. If you've ever cooked, baked a cake or made biscuits or cooked with your mom or your grandma or somebody, and you use flour, the powdery flour to make cake or biscuits, that fineness, if you spill it, it goes everywhere. That's about the size of the dust particles on Mars. So this is another thing you have to think about if you have all kinds of equipment, if you have rovers, if you have spacesuits and there's a dust storm and that fine dust gets in the articulated areas of your spacesuit, how is that going to affect a human mission? Another thing to think about. All right. This is an old map. This is Schiaparelli's famous Mars map. He drew this, he looked through primitive telescopes and he termed these little canal type things as canali, misinterpreted in English as canals, but it really meant channels. But when it was misinterpreted in the newspapers, because in 1877 there was no internet, so it took a long time for news to get from one part of the world to the other. So it was misinterpreted. So people thought, oh my God, there must be somebody living there. But it was just a misinterpretation in the newspaper. These are Percival Lowell's drawings. He built the Lowell Observatory. It is in Arizona and it still stands today. If you ever go there, it's really awesome. And these are some of his original drawings. He was a big Mars fan. Then fast forward to 1999, one of the first Hubble images of Mars. And this is kind of a spread out map. Sometimes you may see these of Earth in your classrooms. And it's showing some clouds and some difference in colors on the surface. And you can see the North Polar ice cap up here. So that is a big change from Schiaparelli's map in 1877 to Percival Lowell in 1914 to Hubble in 1999. And now we have much clearer, precise images where you can see, a pebble on the ground. So the surface does change throughout the year because of the dust storms, and it can be engulfed for months at a time. So can anybody tell me what, aside from what I already mentioned, what could be a problem if you are on Mars and you have your people living there for 18 months, let's say? What's a problem that a dust storm could cause the humans? Does anybody have any ideas?
Noise pollution due to hitting the material.
Noise pollution, that could be a psychological problem. Okay, that's a good idea. Anybody else?
Solar panel obstruction.
Perfect. Solar panel obstruction. So the dust, when it settles, And if you are using solar panels, so remember, there's no fossil fuels on Mars. Everything has to be, either solar panels. I won't give away all the answers, but there's other other ways you can use power. Probably solar panels would be the first way. They get covered by the dust, and then what happens? You're going to lose power. So you have to think about that when you're planning your mission. Here's an image of a Martian dust storm from probably, I don't know, 30 years ago or so. And you can see it looks very hazy. It's not sharp and clear like the first image I showed you. Very hazy. And it does engulf the entire planet. So here you see, here's the first clear image, no dust storm. Here's the second image with a dust storm. And you can see at the bottom of the image on the right, the south polar ice cap. It's much smaller than the northern ice cap. All right, so in the 1970s, which to you guys seems like eons ago, the Viking orbiters, we sent orbiters and landers to Mars in the 70s. They were very successful. They took thousands of images. Then the Mars Global Surveyor from 96 to 2006 mapped the surface of Mars with within an accuracy of a few meters. And now our satellites even get closer than that. It used a laser altimeter to map the surface. So these are important things. All right, so there's a difference. So when you're planning your landing site, think about the difference between the northern and southern hemisphere of Mars. The northern hemisphere has rolling volcanic plains. The southern hemisphere is heavily cratered. However, there are reasons why you might want to land in a crater. There are reasons you might want to land on a volcanic plain. So if you think about these pieces of information listed here, you may come up with a plan with your team of why you want to land in a certain place. Think about all of the things a human may need, the most important things a human needs. Where would you want to land? You have to think about safety of the spacecraft, safety of the crew, resources that you can get from the planet itself. Because the more resources you have to bring, the more complicated your launch and landing will be. But you're not planning the launch and landing, but you do have to take those things in consideration. Here we go. So this is a topographic map of Mars. The blue is the lowest lying regions. And then these little white peaks here, I don't know if you guys can see my cursor. These are the volcanoes. So these white peaks are the highest regions. So you can see the northern hemisphere is much smoother and shallower as far as the height of things. And the southern hemisphere is much more bumpy, much more cratered. We have the Tharsis Bulge, which is the only so-called informally called continent on Mars. It is on the opposite side of the planet as the Valles Marineris from the first picture, the Big Canyon. It's on the opposite side of the planet from that. So that's something to think about. The Hellas Basin is a giant ancient crater that is very, very big. It's about 3,000 kilometers across. And it appears to be an ancient 4 billion year old impact site. So some people theorize that this impact site here was helped crack open the opposite side of the planet where Valles Marineris is. Some people theorize that. We don't know for sure. Here's the opposite side of the planet. Here's Valles Marineris. It's 4,000 kilometers long and 120 kilometers at its widest. So this has quite a depth to it. And hopefully we will be exploring this with humans or robotic rovers in the future. And here's more details about that. Here is Olympus Mons. It's the largest volcano in the solar system. Who can tell me what a caldera is? Can anybody tell me what a caldera is?
a depression formed when a volcano erupts.
Right, correct. Right here, if you can see my cursor, I hope you can. At the top of a volcano, you have a caldera. It looks like a crater, but it's really from when all of the lava spilled out, in this case, millions of years ago, probably. The lava came out and then it cooled off and dried, solidified, and then it collapses in, leaving what looks like a crater. We call it a caldera. So this is, if you were flying towards Mars and you could see the planet out your spaceship window, and if Olympus Mons came into view on the rim of the planet, it literally is like a bump on the surface of the planet. It's quite beautiful if you look at images. And it's such a big volcano because there's such low surface gravity. A volcano on Earth can't get that big because we have more gravitational pull. Here are this is a close-up of the caldera, and this is where it is on the planet on the right. And then here are the other three volcanoes I was telling you earlier, those three dots. These are the other three major volcanoes, and they're adjacent to Olympus Mons. So this was a highly volcanic area to the west of Valles Marineris. All right, Martian cratering. There are lots of craters on Mars. There are lots of reasons why craters are important areas of study. We have had, I want to say, 4 or 5 rovers that have explored Martian craters. And they're very important places to explore. I won't give you all the reasons why. You will have to look that up because it's part of your exploration of what you need to find on Mars to live. All right, here is on the right, my favorite crater on Mars. It's called Victoria Crater. There was a rover here for a long time exploring the edge, trying to make its way into Victoria Crater. I don't think they ever made their way in there because they were afraid the rover was going to tip over. But this is a very, very large crater. You'll see it in posters and TV programs. It's famous. Water on Mars. Okay, so I've been a proponent of water on Mars, believing that water was on Mars since way before anybody ever admitted there was water on Mars. If all of the subsurface ice melted on Mars, the planet would be covered in, a few hundred feet of water. So there's a lot of water available on the planet, but it's frozen mostly. There are some very likely underground rivers, springs, pools of water underground where there are briny salts and minerals that keep it from freezing. So where we find water on Earth, what do we always find where we find water on Earth? Anybody know? It's the most important. Oceans, what's in the water? Anytime you find a puddle of water outside in the woods or wherever, what's always in water?
Bacteria.
Bacteria, life. Where we find water on Earth, we always find life. Whether it's bacteria or little tiny brine shrimp or a frog, whatever it is, there's life always exists in water on Earth. So that is why we need to find out how much water we can have access to on Mars and what's in it. And are there living things there? Think about if you go to Mars with your crew, what will happen if you find life there? What are the potential problems it could cause? You need to think about that when you do your report. What are the potential problems that could happen if you found a bacteria on Mars? I'm not going to tell you right now. You have to figure it out. So isn't there water on Mars? We know now There's definitely lots of water there. It's been debated and debated and debated. And about every 6 months, you'll see an article that says, we found water on Mars in the form of a big glacier. They report it repeatedly. I don't know why they keep reporting it, but they pretend they keep finding it. It's there. I have a lot of opinions about it. So it's important to know we need water as humans. So when you're researching your paper, think about how you're going to get fresh, clean water. All right, so these are, I'm not going to go through this for long. This is from a textbook that I used to use, pictures of runoff and outflow channels on Mars that show ancient areas of water. This is the Mars Global Surveyor, that's a satellite that imaged this river delta. I want to say this is near where the Perseverance rover landed. I'm pretty sure. But you can see it looks just like a river delta on Earth. So here we have, this is an Earth on the left, river delta on riverbeds on Earth, and on the right, ancient dried up riverbeds on Mars, showing there was ample water there. These are images. The one on the left was the far left, August 99, was taken by one of the satellites, and then the middle left, September 2005, you can see a new deposit coming down the slope of the side of that crater. That very likely, in my belief, is caused by water erupting underneath the surface of this crater and pouring out onto the surface of Mars with, like I mentioned before, minerals and salts to keep it liquid under the conditions, the freezing and low pressure conditions and low temperature on the surface of Mars. And my belief, people argue this still, is water comes out, drains down the side of the slope there, and the water evaporates and leaves behind the mineral salts. Like if you've ever gone swimming in the ocean and you get out of the ocean and you dry, but you still have salt on your body, same type of thing. And then the picture on the right was by the European Space Agency. This is a crater on Mars with a huge, big piece of ice and snow inside of it, made of H2O. This is a river, well, what I believe is potential riverbed on Mars on the left, and then comparing it to what the Colorado River looks like on Earth. This was subsurface ice taken by the pictures by the Phoenix lander. Oh no, the diagram disappeared when I converted it. Sorry about that. This ice you can see changed from the picture on the left to the right. It was sublimating, meaning going from a solid state to a gaseous state just over a few sols. A sol or a sol is a Martian day. So there was arguing for many years about what was happening here. But the consensus is this was water ice that had sublimated. And we would call it evaporated because we would go from liquid to gas, but on Mars it goes from solid to gas. That's called sublimation. Here are some snow gullies. This is a picture on Mars on the left. You can see snow on the edges of this crater, and on the right, you can see clouds. So these are photos from Mars. And then this was from the Viking lander in the 1970s, snow or frost on the surface of Mars. And that is H2O, not CO2. So permafrost, there's a layer of permafrost under the surface of Mars, so permanently frozen water ice. We can see if a meteor impacts the fluidized muddy ejecta. When the meteor impacts, it causes heat to melt the water, mixes with the dust and dirt on Mars and makes mud. And in some places on Mars, ice makes up 50% of the dirt. So there's ample water ice available. oh, this also refers to the textbook, but we do know that there are new water deposits on Mars. There's something called recurring slope lineae. If you type in RSL Mars, you'll see a bunch of information about it and people arguing back and forth. But there's definitely water underground on Mars. And then the polar ice caps we spoke about earlier. So does anybody have any questions, comments, or anything about the information I covered today?